Electricity 5, Complex Circuits. The lesson day was Wednesday, June 4th, 2014. It's by Bella Zhu, Gurkhan Dhani, and Kimberly Tong. Hey guys, today we'll be talking about complex circuits for those of you who missed the lesson or just didn't quite get it. So let's talk about what are complex circuits. So basically, a complex circuit is a network of circuit elements that we choose to think as one group. And complex circuits are usually elements in series and parallel combined together. So here's the illustration of the complex circuit we were studying for that lesson. So as you can see, there are three identical bulbs, a 3-volt battery, a switch, and a lot of wires connecting it together. And so basically, when this switch is open, A and B bulbs, they're connected in series. When the switch is closed, bulb A is in series with a parallel combination of B and C. And from the last lesson we learned, the total resistance gets smaller when more elements are connected in a parallel circuit like here. And that way, we can predict the resistance of the network BC is smaller than B alone. And with the smaller total resistance, we are guessing that the current through bulb A will be faster when the switch is changed from open to closed, and its brightness will increase. When the switch is closed, what do you think the relative brightness of the three bulbs will be?
Okay.
Alright, so now let's look at the circuit we built. So by observation, the brightness of bulb A and B are the same when the switch is open. So that means the brightness of A1 is equal to B1. Now, when we close the switch, bulb A's brightness will be bigger than bulbs B and C. The bulbs B and C right here will be the same since they're connected in parallel. Bulb A, by comparison, is brighter than both of them. But there is one difference that's not in our prediction. Once we close the switch and bulb A got brighter, bulb B also got dimmer than what it was before. And so what happens here, the current through the battery increased, so the total resistance of the circuit decreased since the voltage of the battery was the same throughout.
Okay.
After adding 3 ammeters at point D, E, and F, we can find the current flow at these 3 different locations. So now when our switch is open, the current flow through bulb A and B are the same, and that's at 0.15 amps. However, when we close this switch, you'll see that the current through bulb B and C is actually 0.1 amps, and that means that the current through bulb A is the sum of the 2 currents coming out of the parallel circuit. And that sum, if you total any of these two, so either bulb A and B or bulb A and C, you'll see that it comes back to that total current that we started off with of 0.3 amps. And so B and C have the same brightness, and A is the brightest of all. And so from this measurement, we can infer that the preliminary rule still works for a complex circuit. The sum of the current going into a junction is equal to the sum of the current coming out of a junction. So we added a voltmeter to measure the voltages across the battery and the bulbs for both situations. And this is the data we got. Okay? So basically, this is the data we got. So we see when the switch is open, the total voltage is 3 volts, and voltage drop across each bulb was 1.5. When we close the switch, however, voltage drop across bulb A was 2, and voltage drop across bulb B and C were 1 volt. And as you can see, the sum of the voltage drop at individual elements does not equal to the voltage rise at the source, which is the battery. So here's the revised voltage rule we made. The voltage rise at the source is equal to the sum of the voltage drops throughout an entire pass through the circuit. So let's sum this all up. In conclusion, a network in a circuit can either be elements in series or parallel, but a complex circuit is those elements combined together. Now the rules for current going into a junction and coming out of a junction can be applied to a network. And basically our new rule for voltage is that the voltage rise at the source must equal to the sum of the voltage drops throughout an entire pass in the circuit. So thanks for listening, everybody. We hope that this video helps you with your exam studies.